Hello everyone, welcome back to my channel to part 6 of number system. Today we will be solving numericals related to number system. So one by one we will be doing the sums. So here comes question number 1. Question number 1 is you have to prove that the number 1 is equal to 0.9 bar. We know the meaning of bar, it means 0.99999. So let us start the answer as let x is equal to 0.9 bar and that is equal to 0.99999 and make this as equation 1. You make this as equation 1. Now, because the decimal point is starting, the decimal point, before the decimal point we are considering 1 0. So therefore multiply the entire equation with 10. So this will come 10x. And if you are multiplying the whole part into 10, it will come 9.999 ... Make this as equation 2. So we have considered x is equal to this and then we are calculating 10x equal to this. Now let us subtract equation 1 from 2. We are subtracting equation 1 from equation 2. How much we will get? 10x minus of x, that will be equals to 9x, and 9.9999 minus 0.99999, that will be equals to only 9, because after decimal point all the 9s will get cancelled. So you will be left with only 9. 9.999 ... minus of 0.999 ... how we will get? These will all come 0. It will be actually 9.000. So that is equals to 9. So from here we are getting x is equals to how much? 9 by 9, that is equals to 1. So what is x? We have taken 0.9 bar. Therefore, what is the conclusion you are getting? That is 0.9 bar is equals to 1. And here is the proof. So right here, proved. This is the first question. Coming to question number 2. You have to classify the numbers as rational and irrational numbers. Classify the numbers as rational number or irrational number. I'm giving you few questions. One, I'm giving cube root of 343. Number 2, I'm giving root 7 by 2. Number 3, I'm given 0.46 bar. Number 4, I'm giving 1.505005005 ... And fifth one, I am giving cube root of 343. Let us start with the answers. First one is given what? Cube root of 343. We know that cube root of 343 means it's actually 7 cubes. 343 is 7 cube. So 7 cube to the power 1 by 3, this is equals to 7, which is a rational number. Coming to the next one, that is root 7 by 2. We all know rationalization. Let's rationalize. How to rationalize? With the root value, we will multiply both in the numerator as well as in the denominator. Root 7 into root 7 is 7, and in the lower part, it will come 2 root 7. As because the presence of root 7, which is not a perfect square, is present in this expression, henceforth, this is an irrational number. Coming to the third example, that is 0.46 bar. This is clearly, it is a rational number. In my previous videos, I have shown you such examples that it will prove that it's a rational number because it's non-terminating and also it's recurring. Coming to number fourth one, 1.50 5005005 ... From the question only you can understand that the numbers This number is not following any particular pattern of repetition. Therefore, it is an irrational number. Coming to the fifth one, that is cube root of 343. Sorry, here it's only square root of 343. Now, 343 is not a perfect square of any number. Henceforth, we can conclude that it is also an irrational number. Now, coming to the third question. Coming to question number 3. Without actual division, find out if the following rational numbers have terminating decimal representation. I'm giving you two sums, 32 by 45 and number B is 17 by 40. I'll show you one, the other one will be a homework. Do practice at home and give me the answers in the chat box. I'll genuinely get back to you. If you have any doubts, kindly write in the comment section. So here we start with the first sum, that is first subpart of question number 3. 32 by 45. What we have to check, what is the number in the denominator over here? 45. If you try to break 45 in terms of prime factors, this will be 3 into 3 into 5. So that we can write it as 3 square into 5 to the power of 1. Now always remember one thing, a number can only have terminating decimal representation if the denominator of the number can be expressed in the form 2 to the power of m into 5 to the power of n. So, but over here, can 45 be represented in the form of 2 to the power of m into 5 to the power of n? We are seeing that 45, we are representing it in terms of 3 to the power of m into 5 to the power of n. So therefore, 45 cannot be expressed as 2 to the power of m into 5 to the power of n. So 32 by 45 is not convertible into the terminating decimal. The second one is homework for you. You will just check whether the denominator can be expressed in this form or not. If it can be expressed, it is a terminating decimal, and if it cannot be expressed, then it's not a terminating decimal. Moving to the fourth question, state if root 7 by 6 root 2 whole square is rational number or not. You have to just check whether this number which I have given, root 7 by 6 root 2 whole square, it's a rational number or it's not a rational number. That you just have to state. Obviously, you have to prove it, or else you can't understand just by looking to the question. So look over here, root 7 by 6 root 2 whole square. This can be written as root 7 into root 7 divided by 6 root 2 into 6 root 2. So what about root 7 into root 7? This is equal to 7. What about root 2 into root 2? This is equals to 2. So here we are getting 36 into 2. That is equal to 7 by 72, which is a rational number. So you have to just simplify it to find out whether it's a rational number or it's an irrational number. Moving to the next question. And this is question number 5. Prove that root 5 is an irrational number by the method of contradiction. What is the meaning of this method of contradiction? That means we will be supposing a statement which will be in contrary to the given statement. Like what we have to prove here, root 5 is an irrational number. So we will be starting with the statement, let root 5 be a rational number. Then at the end of the proof, we have to show that root 5 is not an rational number. So therefore, it's an irrational number. This is known as method of contradiction, that we have to first and foremost consider a statement which will be in contrary to the given statement in the question. Then we have to prove that whatever we have supposed, it is wrong. This will be the method of contradiction. So what is given in the question? Root 5 is an irrational number. Sorry, this you have to prove. So whatever we have to prove, we cannot start the proof with that very statement. So let's take a statement which is in contrary to this statement. So let root 5 be a rational number. And we know that any number which is a rational number, it can be expressed in the form of p by q. Now suppose if you are squaring both sides, then it will be root 5 whole square equal to p by q whole square. In bracket you can write squaring both sides. So from here, how you can get root 5 whole square is 5. This side you can write it as p square by q square. So from here you can write p square is equals to 5q square. P square can be written as equal to 5q square. From here, can I write q square is equal to p square by 5? Here I am writing q square equal to p square by 5. From here, it is clear that 5 divides p square, and also we can say 5 divides p. If p, suppose I am taking as 5, so p square by 5 will be equals to 5 into 5 by 5. So if 5 is dividing p square, so obviously 5 will divide p also. That means if 5 is dividing 5 square, obviously 5 will divide 5 also. So from this very statement we can write, from this part actually we can write 5 divides p square, and which will imply that 5 will divide p also. Coming to the next part. So what we have got here, that 5 is dividing p, which we can write in this form. 5 is dividing p. 5 divides p. Therefore, we can write over here that p is equal to 5 into some constant c. That means p will be a multiple of 5. If p is a multiple of 5, only then 5 can divide that number. If p is a multiple of any number other than 5, can it get divided by 5? Not possible. P has to be a multiple of 5 to make this number p divisible by the number 5. So let us take that p is equal to 5 times any constant c. 5 times any constant c. So if I am squaring both sides, I will get p square equal to 25c square. Right over here, squaring both sides. Right over here, squaring both sides. So we have got p square equal to this. Now what is the value of p square from here? Make this equation 1. P square equal to 5q square. Write it from here. 5q square equal to 25c square. and in bracket write down from 1. Implies we can write over here q square equal to 5c square, dividing by 5 all throughout the equation. So you will get q square equal to 5c square. So from here you can get that 5 divides q square. Same criteria. So from here we can say that, so you can write it over here that c square equal to q square by 5. So 5 divides q square, same thing, same logic, and 5 will divide p also. Sorry, 5 will divide q also. So here we are getting 5 divides p square and 5 divides p. Here we are getting 5 divides q square and 5 divides q. So 5 is coming in common to both p and q, yes or no? So we can say that hence 5 divides both p and q. That means 5 is a common factor to both p and q. But we know that if a number is rational number, there will be no common multiple other than 1. But we are getting a number 5 which is other than 1 and which is a common to both p and q. So so whatever I have considered that root 5 is a rational number, is it holding true? It's contradicting my statement. So therefore we will write, therefore our assumption is root 5 is a rational number is wrong. Therefore root 5 is an irrational number. So first I have taken root 5 is a rational number. I have proved that my assumption is wrong. Henceforth we can take the contrary, that root 5 is an irrational number. This type of questions are very important for your school mathematics in class 9. If any number they are asking root 3, if they are telling that root 3, prove that root 3 is an irrational number, in that case 3 will be coming in common to both p and q. If suppose they are asking that root 17 is an irrational number, then 17 will be coming common to both p and q. Your homework is that you will try out that root 3 is an irrational number. You will at home, you will just try out. Homework is you will try out that proof that root 17 is an irrational number. If you have any doubts and queries, please write in the comment section. I'll genuinely get back to you. Coming to the next question. So these type of questions are very important for your examinations. Now here we come to the next question, that proves that root 5 minus 2 is irrational number. How we can prove that root 5 minus 2 is irrational? Again, by contradiction method only, let us suppose root 5 minus 2 is a rational number. Then we can write that, therefore root 5 minus 2 can be written in the form of p by q. Now let us take that this is instead of p by q in this question, we will take this as x for making easy calculations. So now we have to square both sides. So it will be whole square, a square plus b square minus 2ab, that is equals to x square. So we are getting this as 5 plus 4 minus 4 root 5 equal to x square. So we are getting this 9 minus 4 root 5 is equals to x square. So from here 9 minus x square equal to 4 root 5 and root 5 is equal to 9 minus x square by 4. Now we know that root 5 is an irrational number. Root 5 is irrational. So therefore, as because there is an equal to sign, 9 minus x square by 4 should also be an irrational number. As because equality sign is there, so if this part is irrational, that side should also be an irrational number. Then x square should be an irrational number. For making this irrational, x square should also be irrational. So from there we can say x must be irrational number. But what we have assumed that x is a rational number, but we have assumed that x is a rational number. A contradiction to our assumption. Therefore, root 5 minus 2 is a irrational number. Proved. Here I end the sums. If you have any doubt regarding any other type of sums, please feel free to write in the comment section. I'll genuinely get back to you. So here I end my first chapter on rational numbers. Please like, share and subscribe my channel and wait for the next chapter to come. Thank you.